Hi class. In the last video we were looking at this figure, and so this is my rendition of a column of air and the distribution of air molecules within this column of air. And we noticed all the impact of of gravity to compress the atmosphere. So most of the air molecules are found closer to the surface and fewer higher up in the atmosphere. And so we left off with this question: is the decrease in air pressure constant with a change in altitude? In other words, does air pressure change at a constant rate as we go up through the atmosphere? And so that's what we're going to take a look at now. This figure is on Canvas in the PowerPoint. There's a PowerPoint slide. I think it's slide number 6 in chapter 5. And so what we're going to do is to demonstrate how air pressure changes with a change in altitude. Okay, and so on this figure we have air pressure on the x-axis, altitude or elevation on the y-axis, and so we're going to take a look at what is the typical air pressure at a given altitude or elevation. Okay, and then we'll also take a look at the change in air pressure as you go up into the atmosphere. So we're going to start off with this figure. Let's make a table out of this. We're going to have 3 columns to our table. And so we'll start off with altitude. And our altitude will be in kilometers. Okay, and then we're going to take a look at the air pressure. Our air pressure will be, if you remember, in units of millibars. And then the third column we're going to take a look at is delta air pressure. The change in air pressure, if you remember from math class in high school, delta means change in. So the change in air pressure. And this will be a change in air pressure in millibars for every, we're going to look at this every 2 kilometers going up into the atmosphere. Okay. So let's start off at the surface. We look over here at the surface. The typical, well, altitude would be 0 kilometers. The air pressure would be about 1,010 millibars at the surface, and we have no air pressure change yet because we only have one level. Okay. When we go up to the 2 kilometer altitude or elevation, so we read this 2 kilometers over to this line here and bring it down. So we find that at 2 kilometers, the air pressure is about 800, and so over here, bring it down, it's about 820 millibars. Okay, so we have a change in air pressure between these 2 altitudes of 190 millibars for every 2 kilometers. Okay, so in this 2 kilometer distance from the surface up to an altitude of 2 kilometers, our air pressure has changed 190 millibars over those 2 kilometers. Okay. So now let's take a look at 4 kilometers. At 4 kilometers, we go up to 4 kilometers, read this over to the line and bring it down, and we see that at 4 kilometers, the air pressure is about 650 millibars. Okay, so for this 2 kilometer distance, we have a change in air pressure of 170 millibars over that 2 kilometer distance. Okay, so as we've gone up from the surface to 2 kilometers to 4 kilometers, has the air pressure decreased? Yes, obviously it has. It's gone from 1,010 millibars at the surface to an average of about 820 millibars at 2 kilometers above the surface. and now at 4 kilometers above the surface, we're at 650 millibars. So obviously the air pressure decreases as we go up into the atmosphere. And if you think back to the definition of air pressure is the force exerted by the weight of all of the air molecules above that given point in the atmosphere. Okay, so every time we go up into the atmosphere, there are fewer air molecules above us, so obviously the air pressure is going to decrease. Then the second question is, at what rate is that air pressure changing? Well, after only looking at 3 different levels here, from 0 to 2 kilometers, our air pressure changed by 190 millibars over that 2 kilometers, and then from 2 to 4, it changed at a slower rate at 170 millibars over this 2 kilometer range. Okay, and you'll see that this is going to be a pattern that becomes established. So let's go up another 2 kilometers, go up to 6 kilometers, read this across and bring it down. So read it across to the line and bring it down to the surface. And we find that at 6 kilometers, our air pressure is typically about 510 millibars. Okay, so the change in air pressure between 4 kilometers and 6 kilometers is 140 millibars over that 2 kilometers. So has the pressure decreased? Yes, it has. Okay. What can we say about the rate of decrease? Well, the rate of decrease, the air pressure is decreasing, but it's starting to decrease at a decreasing rate. Okay. Let's go up to 8 kilometers. At 8 kilometers, okay, if we take our line here, 8 kilometers, read over to this line here on the curve and bring it down, we'll notice that that's at 8 kilometers. At 8 kilometers, the air pressure is typically about 400 millibars. The difference here is 110 millibars. So has the pressure decreased? Very definitely it's decreased. What can we say about the change in air pressure? The change in air pressure is decreasing. Okay. Let's go up to 10 kilometers. At 10 kilometers, if we start here at 10 kilometers, read over across to this line and bring it down, we notice that the air pressure at 10 kilometers is typically about 320 millibars. And let's look at the change in air pressure. Between 8 and 10 kilometers, it's changed 80 millibars. Okay. So is our air pressure changing? Is our air pressure decreasing as we go up into the atmosphere? Very definitely. Okay. What about the rate of change? The rate of change is also decreasing. So the air pressure is decreasing at a decreasing rate. We'll do one more level here. Let's go up to 12 kilometers. At 12 kilometers, read it across to the line, bring it down. We see that we are at, at 12 kilometers, we are at 250 millibars, and our change, okay, is 70 millibars over that 2 kilometer change. Okay, so at this point we can make an observation, okay, that as altitude increases, okay, so the first thing we could say is as altitude increases, the air pressure decreases. So as altitude increases, air pressure decreases. Okay, and what can we say about the rate at which the air pressure is decreasing? So as altitude increases, pressure decreases, but notice the rate of change is decreasing. So as altitude increases, air pressure decreases, sorry about that. Okay, and air pressure is decreasing at a decreasing rate. Okay, so from this figure, we can get this concept then that as altitude increases, okay, pressure is decreasing, but the pressure is decreasing at a decreasing rate. Okay. Now, you can go ahead and memorize that if you want to. It's better to understand it, because you can also turn that around and say, well, whatever goes up must come down. So what happens when you start at 12 kilometers and work your way back to the surface? So maybe you're in a commercial jet and you're going up into the atmosphere. As the altitude increases, the pressure is decreasing at a decreasing rate. But eventually that airplane has to come back down, so when it comes back down towards the surface, what can you say? When the altitude decreases, okay, as you come back down towards the surface, the air pressure is going to increase, okay, and it's going to increase at an increasing rate. So you have to think both ways here. You just can't memorize this in one direction. Okay, I'd rather that you understand it, and so that you can understand what happens as you go up and as you go down. Okay, as you go up, pressure decreases at a decreasing rate. As something starts up in the atmosphere and comes back to the surface, the pressure increases at an increasing rate. Okay, so that's what you need to get out of this figure. Actually, there is one more thing that you need to understand here, and it relates back to this figure, okay, our column of air. Okay, and so again, we say that because of gravity acts to compress the atmosphere, so your greatest density of air molecules is near the surface. The air molecules are most closely spaced near the surface, and as you go up into the atmosphere, the spacing of the air molecules increases. So there are fewer air molecules the higher you go up into the atmosphere. Okay, now we can use this figure here to also look at at this figure. This is slide number 6 on the PowerPoint presentation. We can take a look at how much of the atmosphere is at a given point. So let's just use as for instance that from the surface, where does the top of the atmosphere end? Just for simplicity's sake, let's just say that the atmosphere ends at 100 kilometers. Okay, it's probably way above that, but let's just, for our simplistic thinking right now, the atmosphere is 100 kilometers thick. Okay, like I said, it's probably way more than that. Where is the halfway point of the atmosphere, not in terms of distance, but in terms of mass? Okay, so you notice that on this figure here, that, and here's the top of Mount Everest for an example here, that you wouldn't even reach the top of Mount Everest, okay, if you wanted to know what's the halfway point in terms of mass of the atmosphere, okay, and again, this goes back to this figure here. Most of the mass of the atmosphere is closer to the ground because gravity acts to compress the atmosphere. So how high up in the atmosphere do you have to go before half of the atmosphere is above you and half is below you? Okay, it actually works out to about 5.6 kilometers. Okay, that's not very high. At about 5.6 kilometers, half of the atmosphere is above you, half of the atmosphere is below you. If you ever get the chance to climb to the top of Mount Everest, this is about 33%, about 2/3 when you reach the top of Mount Everest, approximately 2/3 of the atmosphere is now below you, and only 1/3 of the atmosphere is above you. Okay, and to push matters a little bit further, and again, assuming that the atmosphere is 100 kilometers thick, once you get to about 16 kilometers, approximately 16 kilometers, 90% of the atmosphere is below you, and only 10% of the atmosphere is above you. Okay? So this goes back to the concept of gravity acting to compress the atmosphere. Most of the air molecules, and therefore most of the mass of the atmosphere, is pretty close to the Earth's surface. Okay? And that is why, as altitude increases, pressure decreases at a decreasing rate. All right, so there's this figure. It's a pretty important concept that we need to understand. All righty, if you have questions, make sure you let me know.